In the 1950s, atomic weapons became the darling of major powers. In addition to well-known weapons such as atomic bombs and nuclear-powered aircraft carriers, nuclear-powered tanks and aircraft were also under development. At that time, people had already recognized the huge damage caused by radiation. Therefore, the use and maintenance of nuclear-powered engines became a major problem. Unlike aircraft carriers or submarines that can have huge spaces, aircraft or tanks would use compact nuclear engines. Maintenance work requires extremely precise equipment. In order to protect the workers and complete the work, the United States designed and manufactured the Beetle mobile robot. The Beetle is an experimental equipment that many people consider to be the first-generation mecha. In fact, it does have the characteristics of mechas and only needs to be equipped with a weapon system. The Beetle is a heavy mechanical equipment weighing up to 77 tons. Although it doesn't look that heavy, the entire vehicle is about 5.8 meters long, 3.66 meters wide, and 3.35 meters high. The designer used an improved chassis from the M42 40mm self-propelled anti-aircraft gun, which had a wider and lower chassis. The mobility system was also modified and strengthened. It was driven by a 500 horsepower engine, but could only reach a maximum speed of 10 miles per hour. Approximately 16 kilometers per hour. It also had a motor that allowed the Beetle to move at a slow speed of 15 feet per minute, approximately 4.6 meters per minute, for fine adjustments. For a mecha whose main task is maintenance, slow speed is completely acceptable. This mecha is manned, with one driver located in a rotatable turret installed above the vehicle. The turret weighs 50 tons, and most of the huge weight is to protect the operators from radiation. There is a 1 foot, approximately 30 centimeters, thick lead plate around the driver, as well as half-inch, approximately 15 centimeters, thick steel plates on both the inside and outside of the lead plate. The driver enters and exits the vehicle through a 7.5-ton heavy hydraulic door that lifts open. In the narrow operating space, the driver cannot even stretch his legs, let alone stand up. He can only observe the front through a 23-inch, approximately 58.4 centimeters, thick glass window. The window is made up of 7 leaded glass panels, providing radiation protection similar to the surrounding metal protective plates. The thick and heavy metal protection is not without purpose. It can reduce radiation by 3,000 times and can operate normally under a radiation dose of 3,000 rems. If a healthy person is exposed to this environment without protection, they would quickly suffer from radiation and die in about 10 minutes. The entire turret is supported by 4 hydraulic supports made of stainless steel, allowing the driver to control the hydraulic equipment to raise and lower the turret. The elevation range can reach up to 15 feet, approximately 457 meters, although this movement process is also quite slow. Thick and solid metal mechanical arms are installed on both sides of the turret, with a pulling force of up to 85,000 pounds, allowing the heavy objects to be pushed and pulled in coordination with the movement of the chassis. At that time, there was no modern smart technology, and all movements were controlled by the driver in the turret without sensors or devices to sense the applied force and precise movement positions. The driver needed to concentrate on operating. The difficulty of operation is probably similar to performing surgery. In the first public demonstration in 1962, the Beetle carefully picked up an egg. A 3-ton air conditioning unit can provide a relatively comfortable environment for the driver because nuclear engines often mean high temperatures. This air conditioning unit can provide suitable humidity and maintain a constant temperature inside the driver's compartment when the external temperature is between 25 degrees and 130 degrees. Because there is no need to consider radioactive dust when repairing the engine, the air intake for the Beetle driver's cabin is not equipped with a filter. The air enters the air conditioning unit through a curved passage, and radiation cannot penetrate the interior at any angle. The driver communicates with the outside through radio equipment, and there are microphones on the vehicle body. The driver can also hear the sounds outside the vehicle in the driver's compartment. which is helpful for his driving operation. The Beetle was originally designed to repair nuclear-powered engines, but soon people realized that the small nuclear engines suitable for tanks or aircraft were not mature at that time, and were also very unsafe. If an aircraft installed a nuclear-powered engine for flight, it would be similar to carrying a nuclear bomb overhead. In the event of an accident, it could cause major casualties. Therefore, the mission of the Beetle was changed to handle nuclear pollution, such as picking up and collecting radioactive objects at accident sites. As the first generation of mecha, the Beetle had many technical problems. It experienced hydraulic oil leaks, malfunctioning mechanical arms, and short circuits, in addition to being impractical. Therefore, only one vehicle was produced.